Okay, so what this machine, this is like a Van de Graaff generator. What it is like a machine for rubbing things together. It rubs the rubber belt against a pulley at the bottom, and then it rubs again against another pulley like inside this silver dome. And so we're just pumping lots and lots of electric charge up onto here. And that means that this silver dome at the top, once the electricity gets up there, because it's a conductor, it can spread out evenly across this whole electric dome here. We're not seeing anything at the moment because I've got the other smaller ball touching it, and then that wire carries any electricity that's pumped up there back down to the bottom. So the electricity at the moment is getting pumped up by the rubber band and then flowing back down through the metal. But what we're interested in today, what we're going to learn about today, is the electrical breakdown of air. So that's the effect that we see during a thunderstorm when the clouds rub together, rub against each other, like hot air and cold air rubbing up against each other in the atmosphere, and that generates a static charge. The same as when you're rubbing wool against a balloon or rubber against a pulley. And what we can see is that even though air, we're used to it being an insulator, we can see that lightning bolt shooting across there. And so, and you might notice that the one that I'm holding is shaking backwards and forwards a little bit. That's not me shaking it backwards and forwards, that is, it's getting attracted and then repelled by the electric force. And so what we're seeing is that there's a high enough voltage building up on this that the air actually breaks down and conducts electricity. What it takes for that to happen is around about 10,000 volts per centimetre. And so we can estimate that we must have so it stops sparking from my hand there. So the maximum spark was about maybe 15 centimetres long, so 15 lots of 10,000 volts, so maybe 150,000 volts building up on this dome here. Compare that to the 240 volts when you plug something into the wall, or 1.5 volts from a battery. Like 240,000 is a really high voltage, and so to get air to break down and conduct electricity, we need to have a really high voltage, but then it does conduct electricity. And if we had lots and lots of charge here, that spark would stay there in the air, it would keep conducting, but because what happens is that all of the charge that's on here jumps across and then the voltage drops away, that's why it doesn't keep sparking. It sparks and then there's no charge, and then the charge has to build up again, and so it sparks again, and so we see that like bang, 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 bang of charge building up, discharge, charge building up, discharge,